Hey guys, we're going to get started with our activating strategy. It says a box 3 centimeters high, 4 centimeters wide, and 5 centimeters long can hold 60 grams of clay. A second box has twice the height, 3 times the width, the same length as the first box. How many grams of clay can it hold? Alright, go ahead and pause me and get started. Alright, so hopefully you did the math. I drew mine out. So if I'm going to double the height, triple the length, the width, and keep the length the same, then that would be 5 times 12, which is 60, and 6 times 6 is 36. So that gives me an volume of 360 cubic centimeters of how much clay that box can hold. Okay, hopefully you're activated, you're ready to go. So yesterday I introduced you to classifying quadrilaterals. Today I'm going to continue to teach you how to classify quadrilaterals using a hierarchy. Alright, so our learning target is I can classify quadrilaterals in a hierarchy based on properties of that category. If you have your notes from yesterday, hopefully these will help you to understand quadrilaterals a little bit better and to use the correct vocabulary. So yesterday your assignment was to rewrite the hierarchy. So I'm going to pull out the hierarchy that we went over yesterday. I actually rewrote it myself. And we're just going to go through this step by step, okay? So the first part, we're going to kind of break it down. If you notice, we start with the largest classification, which is the most that it can hold. So polygons could be triangles, quadrilaterals, polygons. I'm sorry, not polygons. Well, they are polygons, but pentagons, hexagons, septagons, octagons, okay? So those are all different polygons. Now, what makes them polygons is they are closed figures that have at least 3 sides and 3 angles that do not overlap each other. They don't go back and intersect. There are no curves. They are all made of line segments, okay? So we start with that as our largest classification. Okay, so moving down, we're going to get more specific, and since we're talking about quadrilaterals, let's go there. So a quadrilateral, in order to be a quadrilateral, you just have to have 4 sides, 4 angles, and be a polygon, which means no curves, no over-intersecting, 4 sides, 4 angles, you're a quadrilateral. Okay, so there are different types of quadrilaterals. One specific type is called a kite, and a kite has 2 congruent adjacent sides and opposite congruent angles, okay? So notice I have tick marks here to represent that these 2 that are adjacent, which means they're right next to each other, joining, have congruent sides. And these 2 have congruent sides as well, okay? So that's a kite, it is a quadrilateral, and it is a polygon, okay? All right, so let's go back over to quadrilateral. So a different type of quadrilateral would be a trapezoid. So a trapezoid has at least 1 set of parallel sides. Now, I want to caution you, don't think, oh, she already talked about this, I'm going to fast forward this. You really need to pay attention to this because this is where it gets tricky. You're going to have to know that a trapezoid is a quadrilateral and a trapezoid is a polygon. You're also going to have to know that a parallelogram can be a trapezoid. You're going to have to know what a square can be, and can a rectangle be something other than a rectangle? So please make sure you listen to this video all the way throughout. Even if you think, oh, I've already heard this before, make sure you're really listening and you really understand this, because your assignment is going to be a little bit more difficult than you're probably assuming, okay? All right, so let's look. So I have trapezoid. A trapezoid, in order to be a trapezoid, you have to be a quadrilateral, which means you have to have 4 sides and 4 angles, and you have to have at least 1 set of parallel sides. And remember that thing, at least 1 set. So you can have more than 1 and be a trapezoid, but at least 1 set of parallel sides to be a trapezoid, okay? All right, so now moving on down to a parallelogram. So a parallelogram, why does this arrow exist here? Why? Because when I move up, a parallelogram can be a trapezoid, because a parallelogram has 2 sets of parallel sides. And to be a trapezoid, you only need one set of parallel sides. So a parallelogram would also be a trapezoid because it has two sets, which means, yes, it has one set of parallel sides. So a parallelogram has two sets of parallel sides. It is a quadrilateral. It is a polygon. Okay? So let's go down further. So a parallelogram can either be a rectangle, a rhombus, or a square. Why? Well, a certain type of parallelogram is called a rhombus. A rhombus has two sets of parallel sides, just like a parallelogram, but it has four equal sides. Okay, so the only thing that a rhombus needs to be is a parallelogram, and it has to have four equal sides. And I put tick marks here to represent that each one of these sides are congruent. Okay, they are congruent to each other. All right, so next over here, another type of parallelogram is a rectangle. And to be a rectangle, you have to have four right angles. Okay, so basically the classification for a rectangle is to have four right angles, be a parallelogram, which means have two sets of parallel sides, have at least one set of parallel sides, like a trapezoid, and be a quadrilateral, just like the other quadrilaterals in here. Okay? All right, and so last, the hardest one to be is a square, because a square has the most things that you'd have to be a square. So to be a square, you have to have four right angles, you have to have four equal sides, you have to be a parallelogram, which means two sets of parallel sides, you have to have at least one set of parallel sides like a trapezoid, you have to be a quadrilateral, and you definitely have to be a polygon. So one thing that I want you to notice is that this arrow here means that's going up is letting you know, and I just drew that over there, you can draw that on the side of your hierarchy, that whenever you're moving up in your hierarchy, it is always true, okay? Always true. But whenever you're going down, it may be true or it may never be true, okay? So let's look at some of that, okay? A quadrilateral can be a trapezoid sometimes. Well, because a quadrilateral can also be a parallelogram, it could be a kite, it could be a rectangle, it could be a rhombus, and it could be a square. So a quadrilateral is not always a trapezoid, okay? A trapezoid is never a parallelogram, because to be a parallelogram, it has to have two sets of parallel sides. But if I were to move going upward, a parallelogram can be a trapezoid because a parallelogram has at least one set of parallel sides. So as you can see, going down the hierarchy, it could be true or it could never be true. But going up the hierarchy, it is always true, okay? A kite is always a quadrilateral, and a quadrilateral is always a polygon. So hopefully that makes sense. Please make sure you're thinking about that as we go through our assignment today. All right, so for our assignment today, we're going to look at the book on page 929. So on 929, it gives you a different hierarchy, and I want you to see something because you can see the hierarchy two ways. You can see the hierarchy where the trapezoid is pulled out into the side, or you can see the hierarchy where the trapezoid is pushed below the quadrilateral. So we're just going to look at this one. Both of them are correct. Both of them are acceptable answers. So in some definitions, they say that a trapezoid has one set of parallel sides. Georgia recognizes it as having at least one set. Okay, so in this case, this hierarchy pushes the trapezoid out to the side. I don't want you to think that what we did, this work over here, is incorrect, because it's not. And I'm going to give you another example. Some hierarchies have a kite pointing to a square. Okay, so the kite is off to the side and then it kind of points to the square. And I'm going to explain why it does that, because a kite has two congruent adjacent sides and opposite angles that are congruent. Well, so does a square. A square can also have two congruent angles because its angles are congruent, and its opposite adjacent angles are also congruent. So in that case, a square and a square could be a kite, but a kite would never be a square. So just want you to know the hierarchy can get a little bit tricky, and that is why in the book it does have the trapezoid pushed out to the side. It's just another way of classifying using the hierarchy, okay? So I just wanted you to see that. All right, so let's look over here. One side of the Renalia building in Madrid, Spain is shown to the right. Describe the attributes of the quadrilateral, then classify it based on its attributes. Okay, so if you look at it, the opposite sides are congruent to each other and parallel. So this is a parallelogram and it has opposite sides that are congruent. The biggest thing that I do not like that the book doesn't have is that this is supposed to really say it has 4 right angles. So because of that, this is a rectangle, okay? All right, so let's look at number 1 on the guiding page. Describe the attributes of the quadrilateral below, then classify the quadrilateral based on its attributes. As you can see, it has 4 right angles. The opposite sides are parallel and congruent, or congruent and parallel. It doesn't matter which one you put here. And there are 4 right angles, so because of that, it is a rectangle, okay? All right, so we're going to go over number 2 here, and then we're going to go over these pages that I have. The design below is made up of a repeating quadrilateral. Describe the attributes of the quadrilateral. So looking at one of these, you can see that there aren't any right angles, but all of the sides are congruent. So because of that, this quadrilateral has 4 congruent sides. The opposite sides are also parallel, which means they'll never intersect each other. So this quadrilateral is a rhombus. All right, so what I wanted to do before you got started on your work was to kind of go over some of the work pages from the book because I want you to have a good understanding of how to use that hierarchy, okay? So let's look at number 1, and I'm actually going to bring this in a little bit closer so that you can see it better. Squeeze in here, and I'm going to slide my PowerPoint over because I don't need as much of it. All right, so describe the attributes of the quadrilaterals, then classify. So let's look at this first one. As you can see, it has 2 sets of parallel sides. It has 4 sides, 4 angles. So because of this, it is a parallelogram, okay? Let's look at number 4. This one, as you can see, it does not have right angles. These are acute angles. This is an obtuse angle. That's an obtuse angle. So as you can see, these are it just has 4 equal sides, but it also has parallel sides. So 4 sets of 4 congruent sides and 2 sets of parallel sides. So that makes this shape a rhombus, or this quadrilateral rhombus. All right, number 5 says circle the quadrilaterals that have all the attributes of a parallelogram. Let's move this out of the way. All right, so what I want you to see is that to be a parallelogram, we used our hierarchy here. Remember, everything going up is true. So a square is a parallelogram. A rectangle is a parallelogram. A rhombus is also a parallelogram. So if I'm looking here at number 5 and I want to circle all of the quadrilaterals that are parallelograms, it would be a rectangle, a rhombus, and a square according to the hierarchy. Okay? All right, so let's look. Let me focus this in a little bit more. Let's look at number 6. Number 6 says circle the quadrilaterals that have all the attributes of a rhombus. So again, I'm going to go to my hierarchy. Remember, going up always, but not necessarily going down. So a rhombus is a parallelogram. A rhombus also classifies as a trapezoid because it has at least 1 set of parallel sides. It is a quadrilateral, and it is a polygon. So when I go back over to look at what a rhombus would be, the only 2 that a rhombus would be a parallelogram and a trapezoid. It would not be a square. It would not be a rectangle because, as you notice, when I'm going up, I don't go up to square and I don't go up to rectangle. Okay, those are on the side and beneath. All right, next one. State whether the following statements are true or false. All parallelograms have opposite sides congruent and parallel. This statement is true. And then this bottom statement, all squares have 4 congruent sides. It's rectangles or squares. All rectangles have 4 congruent sides. That is not true, as we know.